The next lesson in Unit 2 polynomials is dividing polynomials. Now we've spent a few lessons on exponents, then we spent a lesson on multiplying polynomials. This lesson is going to be on dividing polynomials. Now there are several methods to divide polynomials. We're going to go over just one of them. So dividing polynomials. There we go. The method that we're going to be focusing on today is what we call synthetic division. And we use this method when we're dividing by a binomial. So you're going to use this method when dividing by a binomial. We're going to be going over 3 problems. Directions will say divide. Let's take a look at example number 1. I've got x squared minus 7x plus 12 divided by x minus 4. Okay, so the synthetic division, the first step in this is we're going to take, there are 3 terms in that first parentheses. It's a trinomial. I'm going to take those coefficients and bring them down. So the coefficient, the number in front of the x squared is a 1, so I'm going to bring that down. This is a negative 7, and this is a 12. Then I'm going to make this box over to the side here, or half of a box. And I'm going to be putting a number there. This is where the second parentheses comes into play. I'm going to take the opposite of what's here. Opposite. So it's a negative 4. I'm going to be putting a positive 4. So whatever number's in that second parentheses with that x, we're going to take the opposite. All right, so I've brought down the coefficients. I've written my number over in that half box to the side. Now I'm going to bring down this first number again. So that first number you always bring down twice. All right, now here's the process piece of this. I'm going to take that number that's on the side, and I'm going to multiply it to this number. So multiply. 4 times 1 is 4. Now I'm going to put 4 times 1 is 4. I'm going to put it right underneath that next blank spot. And then I'm going to add. So 4 times 1 is 4. Add this up. Negative 3. Now I'm going to do the process all over again. I'm going to take this 4, multiply it to negative 3, negative 12, add that up. Now that last number is always our remainder. So 12 plus a negative 12 is 0. That means I don't have a remainder. Okay, so when I write my answer, now I'm done with the process. Now I just have to take this 1 and negative 3 and write it in as an answer. What I'm going to do is I take a look at the largest exponent, which is 2. It's going to be 1 less. 1 less than 2 is just x to the first power. So it's 1x to the first power. Now this has an x. 1 less than that is no x at all. So this is going to be our constant. So 1x minus 3, and I really don't need that 1 there. So my answer is x minus 3. Now, what we're really doing is undoing the FOIL or box method. If I take this x minus 3, put it in parentheses, and multiply it to the x minus 4 using the box or FOIL, I'm going to get the x squared minus 7x plus 12. That's just a way to check your answer. Let's take a look at number 2. I've got 6x cubed minus 19y minus 19x squared plus x plus 6 divided by x minus 3. Now, if you notice, this is set up a little bit differently than the first problem. In the first problem, I had a division sign and then 2 sets of parentheses, one before the division sign, one after. Here I actually have a fraction. So I'm going to rewrite it as a division with the division symbol. So I'm going to have 6x cubed minus 19x squared plus x plus 6 divided by x minus 3. So 6x cubed minus 19x squared plus x plus 6 divided by x minus 3. All right. Now, if you notice, I now have a 3 here. In the first problem, my largest exponent was a 2. Now, it doesn't matter what the largest exponent is. You have to make sure every exponent is there in descending order. Meaning, if it starts off with a 3 like it does in this problem, I have to have a 2 as an exponent, and I have to have a 1, which I do. It's 3, 2, 1. So I'm good. I think it's the next problem where I'm going to have to do something to make it work. All right, so your first thing you should be doing is checking to make sure all the exponents are there in descending order. Now I'm going to bring down the coefficients. So I've got 6, negative 19, 1, and 6. I've got my half box over to the side here. I'm going to take the opposite of this number. So the opposite of a negative 3 is a positive 3. I'm going to bring down this 6 again. Now I'm going to take that 3 and multiply it to the 6. 3 times 6 is 18. Add that up. Negative 1. 3 times negative 1 is negative 3. Add that up. Negative 2. 3 times negative 2 is negative 6. Add that up. This is going to be my remainder. 0. So I don't have a remainder. It must be the last problem I'm going to do that will have a remainder. All right. So we finished the process. Now I'm going to take those 3 numbers and write it as an answer. My largest exponent is x cubed. So when I write this, it's going to be 1 less. So I've got 6x squared. 1 less than x squared is just x, so minus 1x. I don't need to put the 1. And then our constant, which is minus 2. And I don't have a remainder. So my answer is 6x squared minus x minus 2. Let's take a look at the final problem that we're going to go over. Number 3. Let's move this over. There we go. All right, number 3. Here's what we have. X to the 4th minus 2x cubed plus x minus 1 times x plus 1 to the negative 1. So I'm trying to show you all 3 ways you're going to see this, or the way that the problem is written out. The first one, there was a division symbol. The second one, there was a fraction bar. And then this last one, I don't even see a division sign. I see this negative 1 outside the second parentheses. All that means is it needs to be rewritten like this. X to the 4th minus 2x cubed plus x minus 1 divided by x plus 1. And you don't have to keep it in parentheses. It's completely up to you. That's all that means. That negative 1 actually means you're bringing that x plus 1 and bringing it down into the denominator. So now we've got our division problem. All right, so let's write this. I've got x to the 4th minus 2x cubed plus x minus 1 divided by x plus 1. Now that we've got it written in the form with the division symbol, I need to make sure every exponent is there in descending order. So I have 4, 3. Well, I'm missing a 2 because it goes right from x cubed to x to the first. So I have to put something there. It's like holding the place of the x squared. So the way that we do that is we put a 0. So it's x to the fourth minus 2x cubed plus 0x squared plus x minus 1 divided by x plus 1. So if there's an exponent that's missing, you're going to put 0 and then whatever that exponent is. If I was missing an x cubed, I'd be putting 0x cubed. If I was missing an x, I would be putting 0x. You don't have to put the 0 in for the constant. Okay, let's bring down these numbers. I've got 1, -2, 0, 1, and -1. I've got my box over to the side. Now this is a positive 1. I'm going to take the opposite, which is a -1. I'm going to bring down this 1 again. -1 times -1 is a -1. Let's add that up. -2 plus a -1 is -3. -1 times a -3 is a +3. Add that up. That gives us 3. -1 times 3 is a -3. Let's add that up. That's giving us -2. And -1 times -2 is a +2. Add that up. Well, this time I'm getting a remainder of 1. Let's make sure you can see all this. There we go. It's a little better. All right. So let's start to write the final answer. I've got x to the fourth, so I'm going to write this 1 less. So 1 less is x cubed. So this is 1x cubed. I don't need to put the 1. And then minus 3x squared. And then plus 3x, and then minus 2. This number right before the remainders are constant. So when I write my remainder, I'm going to write it as the remainder over the divisor. So it's going to be 1 over x plus 1. Since it's a positive, I'm putting a plus. If it was a minus, if this was a negative, I'd be putting minus. So the remainder is written 1 over whatever this is. It's x plus 1, so that's the way I'm writing it. My answer is x cubed minus 3x squared plus 3x minus 2 plus 1 over x plus 1.